Greetings and welcome to the series of lectures on rational expressions and rational functions. Lecture 5.5, Equations with Rational Expressions. When working with math, we really do want to just follow the steps that are set up for us. We want to follow those rules. So when solving equations with rational expressions, the first step we want to do is find the LCD for all the denominators. Then we're going to multiply both sides of the equation by that LCD to clear the fractions. We're going to use the addition and multiplication property of equality to solve for our variable. So that's kind of it. There's three major steps. So let's take a problem. Let's take a problem like x over 2 minus 3 equals 2/3. First step, let's find the LCD of all the denominators. The denominators are 2, 1, and 3. Therefore, the LCD will be 6. Well, now we're going to multiply both sides of the equation by 6. Okay. So both sides of the equation by 6. Okay. X over 2 minus 3 over 1 equals 6 times 2/3. 6 times x, 6x over 2. 6 times negative 3 is negative 18 over 1 equals 6 times 2 is 12 over 3. Now we're going to reduce those fractions. 3x minus 18 equals 4. Step 3, we're going to use our addition and multiplication properties of equality to solve for our variable. Plus 18 3x equals 22. Divide each side by 3. X equals 22 over 3. So the first step, I think, is the only new step that we have, is multiplying by LCD to clear out the fractions, and then going through and using our addition and multiplication property of equality to solve for the rest of the problems. Now, we've seen this before when we just have numeric values or just one variable floating around. With rational expressions, we also need to be aware of our limitations on our variable. Here's what I mean. Let's take another example. 6 over a minus 4 equals 3 over 8. Now here's what I mean by limitations on our variable, also known as restrictions on our variable. We do not want denominators to be 0, so we need to find the restriction on our variable where that makes that happen. What value of our variable makes the denominator to be 0? So a minus 4, if we set it to 0, we will find what our restriction is. Add 4 to both sides. When a is 4, our denominator will be 0. So our restriction a should not equal 4. A can be anything else, but as soon as a equals 4, we're in trouble. That may or may not be the case, but now that we know what our restriction is, we can work through the problem. All right, what is our LCD between 8 and a minus 4? You cannot separate the a and the 4. That's one full unit. Well, our LCD will be 8 times a minus 4. So we're going to multiply both sides by this LCD. A minus 4 times something will equal 8a minus 4 times something. All right, 6 over a minus 4 and 3/8. Well, I'm not going to multiply through. I'm going to reduce before I multiply. A minus 4 a minus 4. So that leaves 8 times 6 is 48 equals 8 will reduce the 8, leaving 3 times a minus 4. Now I just solve with the addition and multiplication properties of equality. 48 equals 3a minus 12. Add 12 to both sides. $60 equals 3a. Divide by 3. And 20 equals a. Now we just have to remember one thing. What was our restriction on a? Was 4. 20 is certainly not 4. So 20 is our answer. And if we wanted to check, we could plug it back in. 20 minus 4 is 16. 6 over 16 would equal 3/8 if we reduce it. Okay, let's work through another problem. Our first step is to find the LCD of all the denominators. So here are our denominators. X minus 2, 3, and x minus 2. Well, the x minus 2 and the x minus 2 have the x minus 2 in common. Therefore, our LCD will equal 3 times x minus 2. We also need to note what our restriction on x is. Our restriction on x, when we set x minus 2 to 0, is 2, because 2 minus 2 equals 0, so we don't want x to be 2. It could be anything else, but not 2. Alright, so let's multiply both sides by the LCD of 3 times x plus 2. Oh, minus 2. Sorry about that. And we're multiplying x over x minus 2 plus 2 over 3 equals 3x minus 2 times 2 over x minus 2. There are some things that I can reduce as I go through. So 3x minus 2 times x all over x over 2 is going to leave me with 3x. 3x minus 2 times 2 all over 3, the 3's will cancel out, leaving 2 times x minus 2. The x minus 2 and the x minus 2 will cancel out, leaving me 3 times 2 is 6. Let's keep going. Let's distribute the 2. 3x plus 2x minus 4 equals 6. Anything we can combine on the left-hand side? Sure enough, we've got 3 x's and 2 x's. 5x minus 4 equals 6. Let's add the 4 to both sides. 5x equals 10. Let's divide each side by 5. X equals 2. Now before I put a box around this answer and say this indeed is my answer, I need to check my restriction. X equals 2, my restriction is x should not equal 2, because mathematically we came up with 2. That's okay, that mathematically we came up with 2. But we need to recognize that there is a restriction. When there is a restriction and we have met that restriction, our answer does not exist. Since we hit that restriction, we're going to say DNE does not exist. There's no solution to this problem, at least not in the real realm. All right, let's work through another problem. Let's go with 5 over x squared minus 3x plus 2 minus 1 over x minus 2 equals 1 over 3x minus 1 times x minus 1. we need to find the LCD. But I can't see what the LCD is quite yet because that first term, the denominator is not factored. So let's go ahead and factor that first term. All right. So x squared minus 3x plus 2 is going to equal x and x. Let's see. Two numbers that multiply to positive 2 but add to a negative 3. They're both negative, 2 and 1. So x minus 2, x minus 1. So I'm going to rewrite the first term. X minus 2, x minus 1, minus 1 over, and just for emphasis I'm going to put some parentheses around each of these. 3x minus 1. Now we need to find the LCD of all of the denominators. My denominators are x minus 2, x minus 1. Second denominator is x minus 2. Third denominator is 3x minus 1. Definitely need a 3. Here's for my LCD. I need this 3. I need this x minus 2. And I need the x minus 1. So my LCD is 3 times x minus 2 times x minus 1. I also need to figure out what my restrictions are. What happens when x is 2? X minus 2 becomes 0, so there's one of my restrictions. And when x is 1, 1 minus 1 is 0, so my other restriction is 1. So my restrictions, x should not be 2 and x should not be 1. So now we know our LCD, we know our restrictions. Instead of rewriting this whole entire problem, I'm going to multiply by 3, x minus 2, x minus 1 on the left-hand side, and do the same on the right-hand side. Multiply by 3, x minus 2, x minus 1. All right, I'm going to do this a little bit quicker. 3, x minus 2, x minus 1. Well, the x minus 2, x minus 1 will cancel out, so that leaves me 3 times 5. Minus 3, x minus 2, x minus 1 times 1 is just 3, x minus 2, x minus 1, but it's all over x minus 2. So the x minus 2 will cancel out, leaving me 3, x minus 1. 1 times 3, x minus 2, x minus 1 is 3, x minus 2, x minus 1, but all over 3, x minus 1 only leaves the x minus 2. Now I'm going to solve for x. Distribute the 3. 3x plus 3. Negative 3 times negative 1 is positive 3. X minus 2. Add any like terms on the left-hand side. It's going to be 18 minus 3x equals x minus 2. Okay. Decide which side you want your variables on. Decide which side you want your constants on. I'm going to go ahead and say plus 3x plus 3x. 18 equals 4x minus 2. Add 2, pardon me, plus 2 plus 2. 20 equals 4x. Divide by 4. X equals 5. And before I put a box around this answer, I want to go back to my restrictions and see if I hit any of my restrictions. My restrictions are 2 and 1. Since 5 is neither 2 nor a 1, I found my answer. All right, let's follow our 3 steps for this problem of 3 plus 1 over x equals 10 over x squared. There's an implied 1 there. So let's find LCD. the LCD of 1, x, and x squared. Well, the LCD will equal 1x squared or x squared. What are our restrictions on x? Set x equals 0, therefore our restriction if x equals 0 or x squared equals 0, well, x squared equals 0 would be 0 as well, so our restriction is 0. As long as the denominator is not 0, we're good. Or, pardon me, as long as x does not equal 0, we're good. Right. Let's multiply both the right-hand side and the left-hand side by x squared. Okay, let's save on paper space. X squared, x squared. X squared times 3 divided by 1 is 3x squared. X squared times 1 divided by x is x. 10 times x squared is 10x squared divided by x squared is 10. Let's move everything to the left-hand side set to 0 so we can use our 0 property, 0 factor property. Minus 10, minus 10. 3x squared plus x minus 10 will equal 0. Now I want to factor. So what two numbers? 3 times negative 10 is negative 30, but I want it to add to a positive 1. So let's see, positive 6 and negative 5 will multiply to negative 30, and positive 6 and negative 5 will add to 1. So I'm going to rewrite that middle term in terms of the 6 and the negative 5. 3x squared plus 6x minus 5x minus 10 equals 0. Now I can use grouping. I'm going to group 3x squared plus 6x, and I'm going to group negative 5x minus 10. I'm going to factor each of these separately. 3x squared plus 6x, let's factor a 3x out. That would leave x plus 2. For the negative 5x minus 10, let's factor a negative 5 out, leaving x plus 2. Well, it looks like they have the x plus 2 in common, so let's factor that out, leaving 3x minus 5. So, x plus 2, 3x minus 5 equals 0. Let's set each of those factors to 0. X plus 2 equals 0. 3x minus 5 equals 0. Let's solve each of these. Minus 2, minus 2. X equals negative 2 for the first factor. Plus 5, plus 5. 3x equals 5. Divide by 3. Divide by 3. X equals 5/3. But don't forget, we have to go back to our restriction and see if either one of these answers hit our restriction. Our restriction is 0. Negative 2 is not a 0, and 5/3 is not a 0. So we have two solutions for this problem. Negative 2 and 5/3. All right, let's try another problem. Y minus 4 all over y squared minus 5y equals 2 over y squared minus 25. We need to find the LCD, but I have no idea what factors I have here until I factor the denominators. So y minus 4, and the factors of the y squared minus 5y is y times y minus 5. 2 all over, and we're going to factor y squared minus 25. It's going to be y minus 5, y plus 5. Now I can figure out the LCD between y minus 5, and y minus 5, y plus 5. Okay. Therefore, the LCD will be y minus 5, and y plus 5. Okay. The first term has the y. Both of them have the y minus 5 in common, and then the second term has the y plus 5. So I need all of them. I also have to figure out what my restrictions are. The restriction on y, well, when y is 0, that makes this denominator 0. When y is positive 5 minus 5 is 0, and positive 5 times 0 is 0. So positive 5 is also a restriction. And over here, negative 5 plus 5 is 0, so that will zero out this denominator. So my restrictions are 0, 5, and negative 5. Now I'm going to multiply both sides by the LCD. Right, the LCD is y minus 5, y plus 5, times y minus 4 all over y minus 5 equals our LCD, y minus 5, y plus 5, times the right-hand side of 2 all over y minus 5, y plus 5. Okay. Before I do all this multiplication, trust me, I want to reduce. Y and y will reduce. Y minus 5, y minus 5 will reduce. So the left-hand side is left with y plus 5 times y plus 4. Oh, minus 4. The right-hand side, the y minus 5 will cancel. The y plus 5 will reduce, leaving me y times 2, which is 2y. I do need to do the multiplication of the left-hand side and simplify and get this set to 0 before I can solve for y. So if I FOIL this, it's going to be y squared minus 4y plus 5y minus 20 equals 2y. Add like terms. Y squared plus y minus 20 equals 2y. Let's go ahead and subtract 2y from both sides. Y squared minus y minus 20 equals 0. Now I want to factor the left-hand side. Y, two numbers that add to negative 20, or that multiply to negative 20 but add to negative 1. Negative 5 and positive 4. Negative 5 times positive 4 is negative 20, but negative 5 plus 4 is negative 1. Now I set both of those to 0. And solve using the zero factor property. Plus 5, plus 5, y equals 5. Minus 4, minus 4, y equals negative 4. Now remember, I always have to check my restrictions. I have two possible solutions, but I have to check my restrictions to see if these possible solutions fail due to my restriction. Alright, y equals negative 5. My restrictions were 0, 5, and negative 5. Hits a restriction, therefore that is not one of my solutions. Negative 4. Does it hit one of my restrictions? 0, 5, negative 5? No, it doesn't. Therefore, y equals negative 4 is a legitimate solution. Now let's go through a different type of process. You're given two variables, this case x and y, and you are told to solve for a particular variable. You've had this in the past, but not as complex. So here's what we're going to do. We're going to follow the same type of steps to solve for our variable in terms of y equals 4 or, x equals 2. But we just want all the y's on one side and all the x's on the other. Okay. I know that was a little weird, but I'm still going to go look for my LCD of both fractions. So on the left-hand side, my denominator is 1. On the right-hand side, my denominator is y minus 2. A 1 and a y minus 2 have nothing in common, therefore my LCD is y minus 2. My goal is to get it to say y equals something instead of x equaling something. I'm going to multiply both sides by y minus 2. Y minus 2 times x equals y minus 2 times y minus 4 over y minus 2. This will give me y times x is xy. Negative 2 times x is negative 2x. Well, the y minus 2 and the y minus 2 will cancel out, leaving y minus 4. Now that I have no more fractions to deal with, I want all of my x types and constant types on one side and all my y type on the other side. And I'm going to select that my y types will be on the left-hand side and my x and constant types will be on the right-hand side. Here's what I mean. I'm going to subtract y. That gives me xy minus y plus 2x equals negative 4. I'm going to subtract 2x, leaving me xy minus y equals negative 2x minus 4. Okay. But you're saying, hey, wait a minute, there's an x on the left-hand side. You're absolutely right. There is a x on the left-hand side, but I can't separate it yet from the y until I factor out that y. I have all my y's on the left-hand side. Now I can factor out the y, leaving x minus 1 equals negative 2x minus 4. I want the left-hand side to only have y, so I can divide by x minus 1, divide x minus 1. Think of that as a 2. If that was 2y, what would I divide by? 2. If this is a 3, I would divide by 3. If this was, a q, I would divide by q. Well, it looks like an x minus 1, so I'm going to divide by an x minus 1. X minus 1 goes away on the left-hand side, leaving me with y equals negative 2x minus 4 all over x minus 1. I have solved this equation for y. Yes, I know there's not just a number on the right-hand side, but it does say what y equals. Let's try a similar problem, but this time let's solve for x. Now, you might want to just flip everything upside down, but that's not the case. You can't just do that. You can't just do the reciprocal of everybody and expect that to be true. So here's what we're going to do. We're going to multiply both sides by the LCD of all the denominators. So the denominators are x, b, and a. Therefore, the LCD will be a, b, x. I just did it in alphabetical order. The order doesn't matter with multiplication, but I just did it in alphabetical order. I'm going to multiply the left-hand side and the right-hand side by abx. All right. abx. abx. Okay. abx times 1 is abx. all divided by x is AB. ABX times 1 is ABX. Divided by B is AX. ABX times 1 is ABX. ABX divided by A is BX. Let's factor the right-hand side. X times A plus B will equal AB. Now, since we're solving for x, I want to get x all by itself, so let's divide by AB. Oops, A plus B. X equals AB all over A plus B. Not quite, just flipping it over, right? Let's start taking it a step further and talk about graphing rational functions. And we need to be very mindful of the restriction on x when we are graphing. Let's take the function f of x equals 6 over x minus 2. The restriction on x is going to be when x equals 2, x minus 2 equals 0, so that is our restriction on x. X we do not want to be 2. So we look for the intercepts. Just like we do with a line, we look for the intercepts. Let's set x to 0. When x is 0, I'm just going to change f of x to a y. It doesn't matter, I can call it anything I want. It's just a variable. It's going to be y equals x over 0 minus 2. Therefore, y equals 6 over negative 2, which is negative 3. So my intercept is 0, negative 3. Let's let y equal 0. When y equals 0, 0 equals 6 over x minus 2. Let's multiply by the LCD, which is x minus 2 to both sides. That will give 0 equals 6. But therefore, 0 never equals 6, and therefore there is not a y-intercept. It doesn't exist. The y-intercept does not exist. So what you're going to do is you're going to build a little table. Build a little table, choose some values for x's, plug it into the equation, and you'll end up getting, and I just chose 0, 1, negative 4, 2, 3, 4, 5, enough values to be able to plot this graph. Remember, if I plug in 0 here, y will be negative 3. If I plug in 1, y will be negative 6. Negative 1 will be negative 2. If I plug in negative 4, I get negative 1. If I plug in 2, 2 was my restriction. I am undefined. If I plug in a 3, I get a 6. If I plug in a 4, I get a 3. And if I plug in a 5, I get a 2. Okay, so I have some points that I can plot, connect the dots, and I cannot hit 2. So you see this red line? I cannot ever hit 2 because that's my restriction. This is what's called an asymptote. Asymptote means it's a boundary. I can't cross that boundary. And since when I let y equal 0, that did not hold true, that does not cross the x-axis. So I approach it very closely to both the asymptote and the x-axis, but I will never cross it. I never cross it. So it's this nice little rounded shape. But I won't cross the asymptote, and I won't cross the x-axis in this case. Let's see the steps that I did to graph that other problem. And let me just mark a few spots here. Finish up my graph a little. Okay, so I have g of x equals 6 over x plus 2. The first thing I do is look for the restriction on x. Anytime I have an x in the denominator, I need to look for the restriction. The restriction is when the denominator is 0. All right, what does x plus 2 equal 0 solve for x? Well, when x is negative 2, that causes the denominator to be 0. Therefore, I have an asymptote at x equals negative 2. I cannot cross this line. That is my boundary. That's my restriction. Okay. Now that I have my restriction set, I'm just going to plot some points. When x is negative 5, I get negative 5 plus 2 is negative 3. 6 divided by negative 3 is negative 2. All right, when x is negative 4 plus 2 is negative 2. 6 divided by negative 2 is negative 3. Negative 3. Negative 3 plus 2 is negative 1. 6 divided by negative 1 is negative 6. Negative 2. Negative 2 plus 2 is 0. That's my restriction. Undefined. Oops, undefined. Okay, that's my asymptote. Negative 1. Negative 1 plus 2 is 1. 6 divided by 1 is 6. 0 plus 2 is 2. 6 divided by 2 is 3. 1 plus 2 is 3. 6 divided by 3 is 2. 2 plus 2 is 4. 6 divided by 4 is 3 halves. 3 plus 2 is 5. 6 divided by 5 is 6 fifths. 4 plus 2 is 6. 6 divided by 6 is 1. And 5 plus 2 is 7. 6 divided by 7 is 6 sevenths. I think that's enough points to kind of get us headed in the right direction. All right, so let's see. Then for another color here, let's try blue. All right, let's plot these points. Negative 5, 1, 2, 3, 1, 2, 3, 4, 5, negative 2, 1, 2. Okay. Negative 4, 3, 1, 2, 3, 4, 1, 2, 3. Negative 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay. Negative 2 is undefined. Negative 1 is positive 6. 1, 2, 3, 4, 5, 6. Well, we know we're not going to jump from this point to this point because I can't cross that line. So my graph looks on the left-hand side something like that. It's a curve. It's a nice curve. And I have enough points to kind of figure it out. Okay, so that side of the graph is done. Let's try the other side. So I have the negative 1, 6, the 0, 3, 0, 1, 2, 3, 1, 2, 1, 2. The 2, 3 halves is 1 1/2. So 2 and about 1 1/2. And you can see it's starting to curve. 3 and 5 6 is just a little over 1. About right there. 4 is 1. And 5 is 6 sevenths, which is just under the line. So you can see we're starting to get this nice curve. You might or might not need more points to figure out this shape. But there we go. I'm not crossing the red line, my asymptote, that's my restriction. And for this instance, it looks like my x-axis is also a boundary because I'm getting really, really close to it on both sides, but I'm never reaching it. Now I just want to show a little bit of comparison. Our first rational function that we did our graph was f of x equals 6 over x minus 2. Our second was g of x 6 over x plus 2. Now I'm trying to get both graphs on the screen at the same time. Maybe I can do side by side a little bit better. No, not really. But let's kind of look at them as best as we can. Okay, I have the curve, but I have the restriction at 2 for f of x. I have the curve, but I have the restriction at negative 2. So it's the same graph, but it's different asymptotes. It's shifted, right? 6 over x plus 2, 6 over x minus 2. So it's basically the same graph, but just shifted. That plus 2 and that minus 2 will shift it. If it was plus 0, the asymptote would be right on the y-axis. If it was plus 5, then it's way over at the negative 5 is your asymptote. So same graph. So keep that in mind when you're working with the graphs. So yeah. So anyway, that's it for this lecture. Until next time. Be seeing you.